Powers of monomials, the essential question, why is it helpful to write numbers in different ways? Let's go ahead and add that to your notes. Alright, so let's make a real world connection to this. If I have an aquarium, okay, let's say I have in my rectangular prism aquarium, and this particular aquarium is actually a cube in shape, so it's all the same size all the way around. I've got this aquarium and it is 2 to the 4th inches long from the top to the bottom, 2 to the 4th inches long. Okay, what I would like to know is that how much water does that carry? Or in other words, what is the volume of this cubic aquarium? So if I take a look, I could say, look, if I know it's a cube, I know it's the same on all 4 sides, or all, I'm sorry, 6 sides. 2 to the 4th, 2 to the 4th, 2 to the 4th. Those are all the sides of my aquarium. I would like to know how much it can actually hold, not just halfway, but fully hold. So if you recall, the formula for volume is you multiply the base, so the 2 bottom numbers, and then times it by its height. So I can write it as 2 to the 4th times 2 to the 4th times 2 to the 4th. And you remember that there was a property we learned called the product of powers property. Remember, it says, look, when I have the same base, I'm allowed to add those exponents and get my final answer. What we'll be learning today is that there's a way to write repeated multiplication, which you probably already know. It's using exponents, that's what that means. But what if I have exponents that are being repeated, like we have here? Well, I can also write this as 2 to the 4th 3 different times to the 3rd power, right? 2 to the 4th times 2 to the 4th times 2 to the 4th, which you see is 12. 2 to the 12th. If I actually did the numbers on that, 2 times 2 times 2 times 2, 12 different times, I end up with 4,096 cubic inches. And that's how that's written, just like that. Now we're going to take this one step further. What if 1 gallon of water holds 231 cubic inches? If 1 gallon holds that much, how many gallons will the tank hold? Well, I know that the tank can hold this much, but I know that 1 gallon of water is only 231. So how would we figure that out? Well, we can take this 4,096, which represents the total volume of the aquarium, and we can divide it by how much each gallon can hold. So total volume of a gallon. So if I take 4,096 divided by 231, I end up with 18 gallons can fit in the aquarium. Sorry about that background noise. I'm doing this after school. Alright, so we have a key concept. This is called the power of a power property. To find the power of a power property, multiply the exponents. What is this power of power? Well, let's take a look. 5 to the 2nd power, then taken to the 3rd. That would be like me writing 5 to the 2nd times 5 to the 2nd times 5 to the 2nd. If I were to expand that out, you can add them all up and get 5 to the 6th, or you can save yourself a step and multiply these two numbers to get here. Okay, there's the algebra portion of it. So go ahead and copy that into your notes. So here's an explanation. 6 to the 4th power, then taken to the 5th power. So really what it's asking for is, I want 5 factors of 6 to the 4th. 6 to the 4th times 6 to the 4th, 6 to the 4th, 6 to the 4th, 6 to the 4th. So I could write them all out, and then I could use the product of powers to add up those exponents all together. So I could write it as 6 to the 4th plus 4 plus 4 plus 4 plus 4. Right? I could add all that up, and I end up with 6 to the 20th. So this is called the product of powers. That's what we learned last time. But we can see there is a faster way to do this. If I have this as my question and that as my solution, can you see how the 4 and 5 relate? 4 times 5 gives me the 6 to the 20th power. So why don't we use that same explanation, right? Instead of expanding it out and then adding the exponents, let's see if we can just jump to straight from there to our answer with a little bit of using the property we just learned, the power of power property. So here we go. I have a base that has a power, take it to another power. What do we do with those two? Well, we multiply it. So that's going to go 8 to the 4 times 3. That should be 8 to the 12th. That's called the power of a power property, and then I just simplified it right there. Here's another. k to the 7 to the 5th. Try it out. Should have gotten k to the 35th power, right? K to the 35th power. Because you take the 7 times the 5, multiply it against 35, and there you go. It's called the power of a power property. Here's another. X to the 4th to the 10th. Well, let's see if you get it. Should have x to the 40th. We're multiplying those two numbers together. All right. Notice all the exponents above had only one base that had an exponent. Right? We only had one thing that was power to a power. Let's see what happens if I have, those are the three examples we had. What happens if I have more than one base? Let's see what that's going to look like. All right, so here's an example here where there's two bases. Look, the 3 and the a are both a base. The a is being squared, the 3 is to the first power, but all this stuff is taken to the 5th. So here's one way I could write it. I could just expand it all out and I say, hey, there's 5 factors to this. 3a squared, 3a squared, 3a squared, 3a squared, 3a squared, 5 different ones. So I could think of this as, all right, well, let me put all the 3's together. 3 times 3 times 3 times 3 times 3. All the a squareds after that. And then, well, really there was 5 3's, 3 to the 5th, and 5 a squareds. And then I can simplify that one step further here and get my answer of 3 times itself 5 times is 243. A squared to the 5th, we learned that. That's the power of a power property. That should be a to the 10th. This brings us to the next key concept. There was actually a faster way of doing that last one. Here's our last property that we're going to talk about today. Power of a product property. To find the power of a product, find the power of each factor and multiply. Say what? Look, I have two bases here. X and y are both the base. I'm sorry, 6 and x are both the base. 6 to the first power, x to the second power. Both of these things are being taken to the third. So what I can do is I can take this 3 and apply it to the 6, which I write it over here, and apply it to this x squared right there. And then you can do that individually. 6 to the third is 216. 6 squared then to the third is x to the 6th. So what is that saying with the algebra? Look, you got two different bases here. You take the power that's out here and apply it to both of them. Let's see what that looks like with some examples. Okay, here we go. Here are my two bases. There's a 4 and there's a p to the third. Okay, it's asking to be squared, so I just take the 4 and I square it, and the p to the third and square it. It's like the distributive property, except kind of backwards here. We'll just go, hey, both of these get that power. It's called the power of a product, and then you simplify it. 4 squared is 16, and then I use the power of a power property to go from p to the third squared to p to the 6th. And that's it. Can't go any further. Let's go with another example. Here I've got 3 bases. -2, m7, and n to the 6th. All of it's being taken to the 4th power. So I take each one of those bases and separate them. I'm going to put them to the 4th power each time. That's power of a product. You can go and simplify that. This turns into 16. This here will turn into n to the 28th, and this is n to the 24th if you multiply those together. Here's one more example for you. So look, I've got 3 bases here. 6, x to the 5th, y to the 11th. All of them are taken to the 4th power. So this 4th power applies to all of the bases, all 3 of them. And so that's going to look like this. 6 to the 4th, x to the 5th to the 4th, y to 11 to the 4th. Just like that. Then we simplify. This turns into my number. X to the 5th to the 4th now is x to the 20th. Y to the 11 to the 4th, y to the 44th. Okay, that's all the notes for this. Hopefully that makes sense. If not, make sure you come to class with questions.